Now, the next one is a super hard problem, okay? Okay, so let's have 6 vertices, and so we can join every 2 of them by a line. Is that enough? Okay. Like, yes, yes. How many lines are there? How many lines are joined between the points? How many? How many lines? Okay, if you can count how many lines, I want to ask you also how many diagonals. So diagonals are those lines that you don't count joining the adjacent vertices. Okay, so how many lines are there? So of course you can count it in 2 different ways. Okay, so first of all, there are 6 vertices, right? 6 vertices, and then each one is joining out exactly with 5 edges. So altogether, there are 6 edges, 6 vertices, each one joined to the others. There are 5 edges, but then each edge is double counted. Okay, a single edge, let's say this edge is counted when you are counting this vertex, 5 lines, and then this vertex, 5 lines. Is that okay? So they are going to be 6 times 5 over 2, and then it is equal to 15. Okay, this is one way of counting. Okay, is that okay? Another way of counting is there are 6 persons or 6 vertices. You pick any 2, they will form a line. Okay, so it is the number of lines must be equal to what? Equal to 6 choose 2. Okay. So this is exactly the same as this number, 6 choose 2. Now usually 6 choose 2, we are going to write it down in this way, 6 choose 2. Okay, it is not 6 divided by 2, it's 6 and 2 with a bracket enclosing them. Is that okay? So how many diagonals we have? So the diagonals will be easy. So you have 6 choose 2 lines, right? And then you minus the outer 6 lines. Then this will be the number of diagonals. Okay? Of course, okay, you can do with a similar idea. You have 6 vertices. It is joining out with 5 edges, but 5 edges, there are 2 that are not diagonals. So it is 6 times 3. Each one is joining 3 diagonals outside, but they are double counted. So it is 6 times 3 over 2. So they should give you the same answer. Is that okay? So 6 choose 2 is 15. 15 minus 6 is equal to 9. Okay, 6 times 3 is equal to 18. 18 divided by 2 is still 9. So you can do this in this way. Okay? So, but I tell you that this is the most difficult problem. Okay, so why? Why is it? So now, because this is not the only problem that we are going to looking at, okay, we want to ask how many intersection points are there. So this is an intersection point. This is an intersection point. So how many intersection points between the diagonals? So this is an intersection point between these 2 diagonals. Is that okay? This is an intersection point between this diagonal and this diagonal. This is an intersection point between this diagonal and this diagonal. And we assume that no 3 diagonals are crossing each other at the same point. So if we draw this like this, so this one is an intersection point. This is going to be different from this one, going to be different from this one. So if we count it, so how many intersections? Let's do this. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So so how many intersections? So there are going to be 15. How many intersection points are there? So there are going to be 15. But how? How can we do this? So how many diagonals? We can have 9 here. How many lines? There are 15 here. So these are the answers. Okay. So it seems like there are 9 diagonals, right? And then 2 diagonals gives you an intersection point. So it looks like this one should be 9, choose 2, right? Well, this is not correct, okay? 9, choose 2 means that if you have any 2 diagonal, there will be 1 intersection point. But it is not true. If you look at this diagonal, and look at this diagonal, these are 2 diagonals, but they don't have any intersection point. So it is not equal to 9, choose 2. Is that okay? Okay, how do you have an intersection point then? What defines an intersection point? Okay. What defines an intersection point? So intersection point, so for a certain intersection point, you must have 2 diagonals. Am I correct? Crossing each other. But then what defines these 2 diagonals? What defines 2 diagonals? So if this is a diagonal, that means what? That means that there are 2 points outside. Is that okay? If this is a diagonal, that means that there are 2 points outside. Is that okay? Is that okay? Does that make sense? So if you give me any 4 points, so let's say 1, 2, 3, 4, 4 points of this polygon, then I can define exactly 1 intersection point by this diagonal and this diagonal. Am I correct? Is that okay? Okay, good. Anyone can tell me what is the answer for this one? How many intersection points are there? It's going to be? Anyone? Every 4 vertex, no matter which 4 vertex you give me, I can give you 1 intersection, right? On the other hand, each intersection, you define 4 specific vertices outside. Okay? So how many intersections are there? This is going to be very good. 6, choose 4. Excellent. 6, choose 4. And 6 vertices outside. You choose any 4, then I give you 1 intersection. Okay, but I told you that this is super hard problem, so this is still not the super hard part. Okay, so we can make it harder. Okay, so what is the hardest part? The hardest part, I will leave you to think about it at home. Okay. So we ask. So now we have intersection points. We have diagonals, right? How many line segments are there? Do you understand my point? How many line segments are divided by these intersections? So you can think of this as 1, 2, 3, 4. So this is 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, 23, 24, 25, 26. And then what? And then 27, 28, 29, 30, 31, 32, 33, 34, 35. It's not done yet. 36, 37, 38, 39. Okay. I hope that I didn't miss anything. So how many line segments are there? There are going to be 39. Okay. Let me quickly check my answer. Is it 39? Yes. Yes, 39. Okay. Yes, 39. So I'll give you a hint. Okay. So number of diagonals turns out to be 15 here as well. Okay, to get the number of line segments, it is based on this number and this number. Okay, think about this at home. Oh, I'll tell you next time, okay? Or you will tell me next time. And finally, I will give you this problem, okay? Okay, so this problem is Star Wars 7, whatever, okay. So Star Wars against alien this time. Okay, 7, okay, 7. Star Wars 7. So what happened? Okay, so let's say this is our Earth. This is our Earth. And let's say this is our moon. This is our moon. Okay. And then somehow there are aliens that attack us. So I don't know how to draw aliens. So alien. Okay, so let's say this is alien. So alien. So these are the aliens. So many aliens. So a lot of aliens. So these are aliens. Okay, so they have very advanced technology so that they have strong weapon to kill us. And in order to defend ourselves, somehow our Earth has also invented very powerful defensive weapon. Okay, so, but then to make the full use of this defensive weapon, we have to transmit this weapon to the moon. Okay, to the moon. So how can we transmit this weapon to the moon? We can use the traditional rockets. Okay. So these are the rockets. It looks like the same, but this is different. Okay, so these are rockets. Okay, these are aliens. Okay, so we can transmit the weapon, put the weapon inside the rocket, and then shoot it to the moon. And then there are people in the moon there to set up this defensive weapon and then help us to fight against the alien. Okay, but then aliens are very smart. Okay, they are very smart. So they can send spy. They can send spy. So the spy is able to do what? Is able to capture our rocket. So if they capture our rocket, they get our weapon. They get whatever inside this rocket, so that we are doomed. They take our weapon, then we don't have any defensive weapon anymore, because they can understand what is inside and find some ways to destroy us. Okay. So, but we are also very clever. So, okay, we don't need to put the same weapon. Okay, one weapon in one rocket. Okay, we have actually 3 rockets. 3 rockets to use. Okay, 3 rockets. So we can put some parts of this weapon in rocket 1, some other parts of the weapon in rocket 2, some other parts of the weapon in rocket 3. So that as long as the parts are delivered to the moon, then people there can set up and then rebuild the weapon. Okay, and the alien, the spy, can only assume, we just assume, they don't have enough people inside. They can only capture one of the rockets. So we are always safe. We can always send 2 rockets to the moon, and they can always capture one of the rockets. Is there a way that we can, okay, cut the weapon, cut our defensive weapon into parts, so that we can safely transfer things to the moon, but then they don't have any benefit of capturing just one rocket? Is there a way? So we can cut. Okay, so let's say there is a weapon. So this weapon, let's say this is a weapon. Okay, so it's a very long arrow. Okay, whatever. So we just have a weapon like this. Okay, what we can do? We can cut it into parts. Okay, if you like, you can cut it into 10 parts or whatever. But a smart person come up with this idea. Okay, let's cut it into 3 parts. Is that okay? Let's call it A. Let's call it B. Let's call it C. Is that okay? A, B, C. Then, good. We build two of these things, so that the first rocket, you send A, B. Is that okay? The second rocket, you send B, C. The third rocket, you send A, C. This is it. So no matter which rocket the spy capture, they only get partial of this weapon, so they don't know the secret. But on the other hand, no matter which 2 rockets are sent to the moon, then what? Then we can rebuild the whole weapon, because we have all the parts. Is that okay? So if you understand what I'm talking about so far, could you please raise your hand? Excellent. Okay, now, of course, we are safe, okay, because we are still here. Okay, and now we have Star Wars 8. Okay. Star Wars 8, same setting, but then what? They have more spies. Let's say they have two of them, 2 spies. And then that means what? That means that they can capture 2 rockets, not just 1. Okay, but then in this Star Wars, we are also richer, so we have more rockets. So we have now 5 rockets. Is that okay? So this is the question that I'm going to ask you to think about this at home. Let me tell you about this answer on Wednesday. How many parts should we cut it into? 5 rockets. 5. Yeah, 5 rockets. Yes, 5. Yeah, because 5 rockets, 2 spy. We get more, they get less. We will have 3 to be sent to the moon, and they have just 2 captured. Okay. So how should we divide the weapon into how many parts? And then for each rocket, what should we put inside? Okay. If you look at the previous problem, so the previous problem, when there is just 1 spy, they can capture 1 rocket, and we can send 2. 3 parts is minimal. We are dividing the weapon into 3 parts, right? We find that the scheme work. But if we divide it into 2 parts, then it doesn't work. Even if we have 3 rockets, okay. Why? We just use 2 parts, it doesn't work. So let's say there are 3 rockets. If we divide it into 2 parts, then let's say we divide it into A and B only. It doesn't work. The reason is that we cannot put A, B into the same rocket. If A, B are put into the same rocket, what will happen? Then the spy will capture this rocket, and then they get the secret. The weapon is no longer useful. So that means that we cannot put A, B together into the same rocket. Okay, so in that case, one of them may be A, the other may be A, and then the other may be B, something like this. Then in that case, the spy just need to capture this B. And then we don't have any B anymore. This is something like the pigeonhole principle. Is that okay? Okay. So one part appears 2 or more times. So that means that the other part appears 1 or fewer times. So in that case, they just capture the fewer parts. We don't get our weapon. Okay, they don't get, but we also don't get. And then we are going to die soon, okay, because we don't have any weapon, and then the troops will come, and then we'll be killed. So 2 parts is not enough for the previous problem. But 3 parts, we just show that a certain scheme works. So 3 parts is an optimal way of cutting the weapon. Okay, so this is the case here. And now we have 2 spy, we have 5 rockets, and then we want to ask how many parts should we cut. So of course you can think of a very fancy scheme that may be cut into 100 parts, but then this may not be the optimal number of ways to cut. So here, come up with a way first, okay? And if you have a way, improve it so that it is the minimum number of parts, okay? And then why I'm asking you this question here, it is because this is a combination problem. Okay, so this is my hint. Okay, think about this at home and then see how you can get the number of parts and then which part in which rocket. Okay, that's it. Okay, thanks all.